Okay, so here we have lesson 523 and 524. It's kind of combined, they're pretty similar. This is about solving systems algebraically. So we have more systems of equations where we want to solve for where they intersect on a graph. Which point do they have that is the exact same point? So here's our problem. Use tables in a graph to find and check the solution for the problem below. Barbara has a bunny that weighs 5 pounds and gains 3 pounds per year. Her cat weighs 19 pounds and gains 1 pound per year. When will the bunny and the cat weigh the same amount? So, we are given information, and the first thing you want to do is create a table that represents that information. Okay, so for the bunny, it weighs 5 pounds right now, but it gains 3 pounds per year. Okay? For the cat weighs 19 pounds. That's a big old cat. Weighs 19 pounds and gains 1 pound per year. Okay? So what you want to do is create a table for each of these. Okay? And the table needs to represent the years, how many years have passed, and the weight. And this weight is in pounds, so LB is the shorthand for pounds. Okay, and you want to write down 2 of these, so I'm just going to copy mine. All right, and one is for the bunny, and the other one is for the cat. Okay, so whenever we have data like this, we always want to start out at year 0, which is like their starting point, or their starting weight in this case. And then let's go up to at least 4 years, okay? And then same thing for the cat. If you wanted to, you could draw lines going across, but you don't have to if you don't want to. Just make sure that they do line up. All right, so for the bunny, it weighs 5 pounds right now. So at the starting point, good, I feel like it's just a rite of passage. I have to yawn at the beginning of every video. So the starting point at this moment is 5 pounds at year 0. So if it gains 3 pounds per year, we need to add 3 pounds. How much will it weigh in year 1 or after 1 year? 5 plus 3 is 8. And again, I guess I want lines because my eyes are not doing too good trying to follow. Try to keep it as straight as you can. Okay. So 8 plus 3 would be 11 pounds after 2 years. Add another 3, 14 pounds. Add another 3, 17 pounds after 4 years. What's crazy is that that's not even as big as the cat yet, right? Our cat here, at year 0, it weighs 5 pounds. Oh, I'm sorry. I was reading the bunny. It weighs 19 pounds, okay? So after 1 year, if we're increasing by 1 pound per year, we're going to add 1 pound. After 1 year, the cat will be 20 pounds. Add another pound, 21 pounds. And again, I'm getting this information from my word problem up here, okay? That's where this info is coming from. And then you continue to add 1 pound to get some more data, okay? So it looks like here in my table, I don't see a common point yet. So this just means I probably need to add some more data, okay? Some of you might be able to see right away. Oh, actually, this one's a little bit tricky. So at first I was like, we just have to add 3 more pounds, and then they're going to have 20 pounds, right? If we add 3 to 17, we get 20 pounds. But that's not our answer. It says, when will the bunny and the cat weigh the same amount? And that means at the same time, right? So the cat might weigh 20 pounds after 1 year, but the bunny, it takes it 5 years to get up to 20 pounds. So we have to keep going, right? Keep on adding more data to figure out exactly when will the bunny and cat weigh the same amount. Please pause the video to do this. See what you come up with. Hopefully you paused. Okay, so if I continue to extend this one here a few more years, and I don't know how many, I'm just going to go up to 10 because it seems like it's taking quite a bit, right? So adding 3 every single time, 20 plus 3 is 23, then 26, 29, 32, 35 pounds. Okay, that's way overweight for a bunny. That's like a small child. Okay, so for the cat here, I see at 4 years, the cat is 23 pounds, but at 6 years, the bunny is 23 pounds. So that wouldn't work. So that means I need to go up a few more with the cat as well. So 5, 6, 7, 8. Let's see if that does it. So if I continue to add 1 pound here, this will be 24 pounds, 25, 26, 27. So now you want to compare the data. Is there a year on here where they are the exact same weight at the same year? And there is. I see at 7 years, the bunny weighs 26 pounds, and at 7 years, the cat weighs 26 pounds. So after 7 years, they will weigh the exact same amount. Now, since I didn't need these, I'm just going to erase these so that I have more room there. And then here as well. All right, so that will be our solution. So what this is telling us, what that tells us, is at 7 years, the cat and bunny will both weigh 26 pounds. And that there is your solution. Okay? Now, we need to show the solution graphically as well. All right, so here's a graph here. Your x-axis is usually your time. And our time in this case is in years. So we need to make sure that we go up to at least 7 years because that's the year that we need to showcase on our graph. So you can either go by ones, which I think that will probably be the best here. Let me see how many there are. So there's 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So since there are 14, I can actually make the graph a little more spread out and make this 1, 2, 3, 4, 5, 6, 7. So I just skipped every 2, right? And that's what it'll give me. It just makes it easier to see the data and to have everything nice and spread out. Now on the left though, we definitely need to go up by ones, and I'm hoping, let me count, I need to count how many dashes there are because we need at least 26, right? So this here, this is the weight in pounds for the y-axis. So let's see here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. Okay, so I barely have enough room. Let me just move some of this stuff over. Whoops, that's not what I wanted. This here. I'm just going to move it right over there. Okay. And then I want to move my Y up as well. All right, there we go. So this will be just enough. So 26 is going to be way at the top. So this would be 1, 2, 3, 4. Another thing you guys could have done is like gone up by 2s. So we could have gone 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. So sorry, I keep hitting my glass. So you could have done that, or you can spread it all the way up. So it's totally up to you how you want to graph that. If I were to do this, then like I might not graph every single point for this cat there, just because there's going to be a lot of in-betweens and like estimations, but it's kind of nice on this grid because the half mark would just be like right there, right? So that's the half. in between there. So that would be like 1 or all the odd numbers basically, right? So let's just leave it like this. It doesn't really matter. So the bunny is green. So I'm going to plot it in green. So its starting weight at year 0 is 5 pounds. So at year 0 here, which is on the y-axis, my starting point, my y-intercept is 5 pounds. So it's going to be right in between the 4 and the 6. And then after 1 year, my bunny is 8 pounds. So at 1 year, I'm going to mark a point at 8 pounds. And then at 2 years, it is 11. So I'm going to go up to right between the 10 and 12. That is 11. And I know I'm adding 3 pounds every year. So after year 3, it's going to be 14 pounds. Oops, that's not year 3, right here. After year 4, it'll be 16. Oh my gosh, did I say 14 or 13? I'm losing my mind. Year 3, will be 14. I was wrong on the year 4. Year 4 will be 17. So right in between the 16 and the 18 there. So I'm just trying to line them up the best I can, like that. Year 5 will be 20 pounds. Year 6 is 23 pounds. Year 7, 26 pounds. And then I could keep on going, because I know it's going to increase by 3 pounds. So 26 pounds plus 3 would be 29 pounds. And then at year 9, 29 plus 3 is 32 pounds. So then you can draw your perfectly straight line. You can also just use a ruler to go all the way here to the end. So this here is the bunny. Okay? And you need to make sure that your points are plotted accurately. You need to have a nice straight line there. So now for the cat, its starting point is at the y-intercept 0, 19. So along the y-axis, I'm going to mark one here at 19. After 1 year, it is now 20 pounds. After 2 years, it's 21. After 3 years, it's 22. After 4 years, it's 23. After 5 years, it's 24 pounds. After 6 years, it's 25. And after 7 years, it's 28. 7 years, 26 pounds. After 8 years, it's 27 pounds. After 9 years, it'll be 28 pounds. Okay, so then if you draw your nice straight line here, and if you plot your points correctly, your ruler should go through all the points perfectly. This is the cat. So here you can see their point of intersection is here at 7, right? If you go down, 7. And then if you go straight across, 26. So that's at 7 years. They both weigh 26 pounds. And that there is their solution to this system of equations. Okay, so pause the video if you need to get this down. I'm going to move on to the next page. All right, so in the problem we just did, we could have written rules. So I'm going to show you how to get these rules exactly. So here, if we're looking at, let's say, the bunny, okay, the bunny's growth each year is 3 pounds. LB is pounds. Its starting point was 5 pounds. So with y equals mx plus b, its growth was 3 pounds and its starting point was 5. That would be the equation of that green line. And that would also represent our table too. If you were to plug in different values for x, you would get these values here that we got for y. Okay, now on the next page they wrote it a little bit differently. They just wrote 5 plus 3x. That is the same as y equals 3x plus 5. They just wrote it where the starting point went first, which is totally fine. So now for the cat, if we were to look closer at the cats here, so the cat's growth is 1 pound per year. Its starting weight was 19 pounds. Okay, so in y equals mx plus b, the growth is 1, the starting weight is 19, y equals 1x plus 19, or you can just write that as x plus 19. And that would be the rule for the cat. Okay, so they wrote the exact same rule, but they just wrote it as 19 plus x. That is the same as y equals x plus 19. They just wrote it with the starting point first. So now there's a way that we can solve this system algebraically without having to do a table and not having to do a graph. So we just solved it with a table and a graph. Now algebraically, we can use something called the equal values method. Okay, so if we have the equations y equals 3x plus 5 and y equals x plus 19, well, if these are within the same system and we want to find where they intersect at, we can set our y's equal to each other. Okay. Right? Because y equals y, right? If we're trying to find when their y's are the exact same and their x's are the exact same, we know y equals y. So here, we can rewrite that y, this y here equals 3x plus 5. And this y over here equals x plus 19. So now we have an equation that is true in this system of equations where we can solve for x. So now we draw a line down the equal sign. You can subtract x from both sides. And pause the video if you haven't done this yet. Please pause the video and try to do it on your own real quick. So once we do that, we're going to end up with 2x plus 5 equals 19. Just bring these down. Now from there, if we subtract 5 from both sides, we get 2x equals 14. And again, guys, the only reason why we could do this was because they were already both equal to y. So sometimes you guys might have to rewrite them into y equals mx plus b form in order to use this method. They have to be equal to y. So now we divide both sides by 2. We get x equals 7 years because my x represents years. So that tells me that they're going to be the same weight at 7 years. So the cat and bunny will be the same weight at 7 years. But what weight will that be? We already know that it's 26 pounds, but we can substitute in x for each of our equations. So if I were to take each of these, let's duplicate them. Okay. If I were to take each of these and now substitute out my x for 7, that one I didn't put parentheses around because I'm not multiplying it. You could if you wanted to, but. So this will become y equals 3 times 7 plus 5. That's for the bunny. And then for the cat, it's y equals 7 plus 19. And that makes sense because if it's just adding on 1 pound a year, you'll be adding on the number of years that pass. So, I mean, you could have written this one as 1 times 7. That would have been fine, but we don't need to do that. So here we get y equals 21 plus 5, so y equals 26 pounds. And we should get the exact same thing for the cat. 7 plus 19 is 26. So the cat and the bunny will be the same weight at 7 years. They will both be 26 pounds because of this. They will both be 26 pounds at year 7. Okay? And that's how we solve it algebraically. So we first used a table and then a graph, and then we used our equal values method algebraically. All right. So now here, Post Falls High School in Idaho has 1,160 students and is growing by 22 students per year. I'm going to pick a color for them. Let's do green. So this is Post Falls High School, has 1,160 students and is growing by 22 students per year. Richmond High School has 1,900 students, or 1,900 students, and is shrinking by 15 students per year. So for part A, it says, without graphing, write a rule that represents the population at Richmond High School and another rule that represents the population at Post Falls High School. Let X represent years and Y represent population. Okay, so we're going to do part A down here. So we have two high schools. We have Post Falls High School, and we have Richmond High School. And let's just remind ourselves about what a linear equation is. Y equals mx plus b, where m is your growth, or what we can call rate of change, because sometimes you're not growing. Like with the Richmond High School, they're actually decreasing, not growing. Growth or rate of change. So it might just be a rate that is changing. B is your starting point, or the starting amount. Okay? So that's important to know. So with Post Falls High Schools, we know that they have 1,160 students. And we're growing by 22 students per year. So plus 22 students per year. Now Richmond High School has 1,900 students and is decreasing by 15 students per year. So will I write plus or minus? This one, to decrease, it's minus 15 students per year. So now what we need to do for part A to finish it up, we have to write an equation for each of these. Y equals something, Y equals something. So using this knowledge off to the left or the right here, please try to write your own equations. Okay, so here, if our growth is 22 students per year, that's what's going to go in for M, and it's going to be a positive 22. So 22 times the year, which X represents the year, plus the students that we've already started. This will tell us the number of students at any particular year, that equation. So this is for Post Falls High School. Now for this one, we are decreasing by 15 students per year. And we started off with 1,900 students. So that would be the rule for this problem. Now, these numbers are really, really big, okay? So we need to solve it now, but we need to solve it algebraically. You could probably definitely graph this online, but I need you to know how to solve it algebraically so that you don't have to rely on a graphing tool, okay? So here we can use the equal values method, where if we have both of these, see if that does it. Okay, so if we have both of these, right, and we want to set y equal to y. Oh dear. There we go. It's going to look like this. So we want to see, okay, when are the y's the same? So y equals y. Okay. Then we take each of the equations. So the green y is 22x plus, and I'm writing way too big, 22x plus 1,160 equals the orange y's equation, negative 15x plus 1,900. Now, this is an equation where you can solve for x. Okay. I just realized this is multiple pages. Did I do the wrong one? Oh no, I think I did the long one. Crap. Okay. Oh dear. Hold on guys, let me just go in and look at my drive real quick. Yeah, I was wondering why this video is so long. Yep, I did not select shorten, so let's see if these do the same things. 'Cause otherwise... Yes, they do. Whew, okay, good. Good. I just made it a lot smaller, so it all fit on one page. Okay, cool. We are good. All right, so if we solve these, I would first start off by adding 15x to both sides. Okay, then here we get 37x plus 1,160 equals 1,900. So now I would subtract this from both sides. Make sure you're pausing if this is going too fast for you. 37x equals, this would be 0, 8, so 740. So divide both sides by 37. And you should get, I believe that's going to be 20. So what this says is at year 20, both high schools will have the same population. So now to determine that, we need to plug in x equals 20 for each of these scenarios here. Okay, so if you plug in x equals 20 for each of these, you can now solve for how many students would be at the high schools. Really, you just need to do this with one of them, but I want you guys to see how you would get the exact same answer no matter which one you use, right? So now we get y equals 22 times 20, it's going to be 440, plus 1,160. That would be 1,600, I believe, students in year 20, since they started taking the data. Okay, so now let's see this one here. So y equals negative 15 times 20 would be negative 300 plus 1,900. That's the same as 1,900 minus 300, which is 1,600 students. Same thing as the other high school. So this shows you how many students will be in each of the high schools at year 20. That is using the equal values method. Okay. Now, down below, you are going to have to solve some of these on your own. Okay. What I'm going to do is highlight some of them. So then you can kind of see like, okay, well, if I set these equal to each other, what is that going to look like, right? And just know that these are two separate problems, okay? So over here, if y equals y, right, because that's what you're trying to figure out, you need to set up your equations. So this y over here, the negative x plus 8, equals the y that is x minus 2. So your first step is solve for x. And your second step is plug in x to solve for y. And the way that you write your final solution is as a coordinate like this, okay? So like up above, if I needed to write my solution, if this wasn't a word problem where I explained it in words, but the solution as a point would be 20, 1,600. That would be my x, y. Okay, and then you do the same thing to the problem on the right. And now these you just need to get them into y equals mx plus b form. So that's just saying to isolate y. So I will do D for you. That's the hardest one. So the first thing I would do is distribute the 2. So then we end up with 2x minus 6 plus 3y equals 0. Now I notice that my y is right here. So I want to just leave that where it's at and move everything else away from that y. So my first thing I'm going to do is move this constant over. So now I'm left with 2x plus 3y equals 6. And now I can also subtract that 2x. And it doesn't really matter where you write it normally, but I want you guys to put it in y equals mx plus b form. So I'm going to write this negative 2x here first. Now the last thing is that there's a 3 multiplying by this y, so we need to undo that by dividing everything by 3. So now we end up with y equals negative 2/3 x plus 6 divided by 3 is 2. And now that is in y equals mx plus b form, where m equals negative 2/3 and b equals positive 2. And that is in your slope-intercept form. This is the slope, and this is the y-intercept. So this is very important for you guys to get really, really good at. Now that's all I'm going to do for you. I'm still grading all of them, so if you need to finish it for homework, that's what you need to do, and then bring it back to me tomorrow, okay? Have a good rest of your day.